Okay, children, today we will discuss gravitation lesson 9th CBSE. Okay, gravitation. Children, whenever we study about gravitation, first we have to study about Newton's law of gravitation. What is Newton's law of gravitation? Newton's law of gravitation. Children, what according to Newton's law of gravitation, it is proposed that if two planets are there or two heavenly bodies are there, whose masses are m1 and whose masses are m2, okay, separated by a distance r or d, your wish, whichever you want, you take, they may attract or they may repel. Anything can happen. They may attract or they may repel. They may attract or they may repel. Children, try to understand. They may attract or they may repel with a force which is directly proportional to product of their masses. Means if their masses are more, force of attraction or repulsion is also more. If their masses are less, force of attraction or repulsion is also very less. Children, see children, sun is there. Around sun, earth and so many other planets are moving. How they are able to move? Because we have centripetal force between sun and earth. Okay, so because sun is also a very big body, earth is also a very huge body, that's why even though they are very very far apart, their force of attraction is very very high. So when two bodies masses are very 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 high, when two body masses are very very high, product will be still more high. So in the same way, the force of they may attract or they may repel with the same force. So more mass, more force. Less mass, less. So force is directly proportional to product of their masses. This is number one. This is universal law of gravitation proposed by Newton. Second, he said that this force is inversely proportional to square of the distance between them. Means if they are very very far, if they are very very far, force will be less. That's all, no? When they are very very far, why the force will be more? If they are very very near, if they are very near, force will be very high. That's what he's saying. Force is inversely proportional to square of the distance between them. Force is inversely proportional to square of the distance between them. Combining these two equations, what you get? F is directly proportional to m1 m2 by r square. M1 m2 by r square. But we can't keep proportionality constant, no children. So removing proportionality constant, we will get g m1 m2 by r square, where g is called as universal gravitational constant. What is the universal gravitational constant? What is G, children? Universal gravitational constant. Okay, children, this is the formula for law of gravity. Universal G is called, children, big G, small g are entirely different, children, and they both are not same. Okay, so you are able to understand. Once again, slowly I will explain one by one. Listen, children. So what I want to say is, all of you see, F is directly proportional to product of their masses. F is inversely proportional to square of the distance between them. Combining both equations, you will get m1 m2 by r square. Removing proportionality, you will get g m1 m2 by r square. Okay, where g is called what? Universal. If you remove proportionality, you have to keep some constant. Universal gravitational constant. Okay, till here, okay, all of you? Very good. Now listen, children. Now F is equal to, we got g m1 m2 by r square. Okay, so g I will keep here. I will take r square upward. So f r square by m1 m2 I will take. Means r went upward, m1 m2 came down. So g value, if you find out, it will be 6.62 into 10 to the power of minus 11. Okay, children, it will be 6.67. It will be 6.67 something they will give, children, into the power of minus 11. Okay, into the power of minus 11. See here, this is square, children. This is square. Newton meter square by kg to kg square. Try to understand, children. Newton meter square by kg square. This is the value of universal gravitational constant. Okay, children, and also if ever you remember, once upon a time I told you how to derive its dimensional formula. Also, once upon a time I told this. How to derive this dimensional formula? Dimensional formula of G. G is equal to, children, F means force. Force means what? Mass into acceleration. All of you know. This is R square by M1, M2. One mass we can cancel. This is only for dimensional formula, children. Okay. And what is meant by acceleration, children? Acceleration is velocity by time. Okay, this is R square into M2, velocity by time. Okay, children. What is velocity, children? What is velocity? Velocity is what? Displacement by time. Displacement by time into R square into M2. Try to understand. Try to understand. Don't get confusion. Okay. So displacement means some distance. L. Radius also some distance. L square. Time means time. Okay. And mass means mass. Okay. Okay, children, this is velocity by time, and here one more time should be there. No, children, I'm sorry. Yeah, see, velocity by time is already there. Velocity displacement by time, no, so one more time. So t square, t into t square. So what you will get, m if it comes up, m minus 1, l into l square, l cube, t minus 2. This is the dimensional formula of G. You need not to remember this derivation, children, just remember this much, it is enough. And a universal gravitational constant dimensional formula is m minus 1 l cube t minus 2. Why it is so important? Means mass comes only negative in universal gravitational constant. That's why it is very, very important. You need not to learn all this derivation, children. Just remember m minus 1 l cube t minus 2. No, sir, we will remember this also. It's very, very good. Okay. Because in your schools, they won't teach all these things, children. In your schools, they won't teach this and this, they won't teach. But till here, they will teach. In your schools, they won't teach this. Okay, now apart from this, I want to say, apart from this, we know now F is equal to G M1 M2 by R square. According to Newton's second law, we know what is F, children. F is MA, Newton's second law. G M1 M2 by R square. Okay, children, we can cancel one mass, one mass. And A also we can write as small g, no, children, acceleration due to gravity. Instead of big A, we can write small a also. Instead of acceleration, we can write acceleration due to gravity also, no, children. Yes. So small g is equal to gm by r square. This is the relationship between big G and small g. What is the relationship between big G and small g? Means small g is equal to big G into m by r square, where small g is acceleration due to gravity, big G is universal gravitational constant. Universal gravitational constant. Okay, children. Again, I'm saying all of you try to understand, children. Don't get confusion. Very, very important. All of you see here, children. Everything I will say again, small I will say, children, so that you should understand. Finally, my concept is so. See, children. F is directly proportional to m1, m2. F is directly inversely proportional to radius. Combining both equations m1 m2 by r square, removing proportionality g m1 m2 by r square, and g value is 6.67 into 10 to the power of minus 11 Newton meter square by kg square Newton meter square by kg square, and g dimensional formula is m minus 1 l cube t minus 2. Now, what is the relationship between small g and big G? I told. So small f is equal to g m1 m2 by r square. From Newton's second law, mg is equal to g m1 m2 by r square. So big small m cancel. G is equal to gm by r square. This is the relationship between small g and big G. This is the relationship between small g. If they ask the relationship between small g and big G, you should write. Now, what are the differences between small g and big G? We will write, children. I will say, and we will stop this class. Tomorrow we'll do numericals on this sum, children. Tomorrow in tomorrow's class we'll do problems, numericals on this, children. Today I'm giving all formulas now. I think you are copying. Everyone, please copy, children. Okay. Now, what is the difference between small g and big G? All of you should concentrate here, children. Big G is called universal gravitational constant. Small g is called acceleration due to gravity. This is the first difference. Okay. Right, understand, children. Next, big G value is 6.67 into 10 to the power of minus 11, and small g value is 9.8. Its units are Newton meter square per kg square. Newton meter square by kg square. Newton meter square by kg square. And its units are, acceleration due to gravity units are meters per second square. Meter per second square. This value, universal gravitational constant, is constant. It is constant all over the universe. Wherever you go in the universe, it is same. All over universe, it is constant. That value will not change. Whereas acceleration due to gravity on the Earth only 9.8. On Earth only 9.8. On Earth. And if you go to another planets, even if you go to Moon also, it is in Moon it is only 1.6. In other planets, we don't know. It depends upon their weight, their height, their diameter, their structure. That is different. Even in Earth also, at different positions, little change will occur. But 9.8 is on Earth only. It changes from place to place. It is not constant. It changes from planet to planet. Whereas universal gravitational constant does not change. And what is its formula? G formula. What is for last difference? Five. 1, 2, 3, 4, 5 differences. If I ask in exam, you should write 5 differences, children. What is G formula, children? G formula is what? F r square. R square will come up. F r square by m1 m2 will go down. M1 m2. Okay, this is formula. And what is the formula for normally we know from Newton's second law, F is equal to mg. So G is equal to F by m. G is equal to F by M. If I ask in exam, write differences between small g and big G, you should write these 5 differences, children. Small g and big G. Okay, I hope you people are copying, children. Start copying fast. Don't waste time. In 10 seconds, I'm giving for you to copy, children. After that, I will stop the recording. Then you can ask me if you have any doubts. Till then, don't ask me any doubts. Okay, please copy, children. Fast, all of you copy.